So since now the equation is exact, so the solution of this equation is represented by a function f, which will be the integral of either of the m function or n function. Okay, so solution can be represented by a function f. So for this we will integrate m, because now m and n are both equal. A partial m and partial m with respect to y and partial n with respect to x are both equal, so we can integrate either m or n. Okay, so this m will be integrated with respect to t. Okay, and execute the command, so it will be this value. Okay, so but this integration, for when we do the hand calculations, comes with a constant in terms of the other function gy, so we need to find that constant. So in this case, what you normally do is, after the finding the function, you differentiate that function with respect to the other variable. So you will take now I will take the derivative of f with respect to, so f with respect to y. Okay, so I will take the derivative of this f with respect to y. So derivative of f with respect to y, so it will be f and then with respect to y. So it is this. Okay, and it will be t over this. Maybe we need to simplify this expression. So simplify, and then so we can use the simplify function. So it is t over t square plus y square. Okay, after simplification. So now we need to compare this f of y with n. Okay, so I can recall n function, which we saved as nn. So I just put nn and then shift enter. So it is this. So if we compare this nn and then f of y, the only difference is e power y of y. So therefore I can say that the g prime of y, okay, that is that was the g was this the constant of integration in this f. It was here, okay, actually, but it did not show up, but in the next step maybe we can show it, but anyway it's there. So this so by this comparison, so g of y, that is the derivative of g with respect to y, will be now equal to e power y of y, e power y of y. Okay, so therefore the function g will be equal to, that is the function of g in terms of y will be equal to the integral of integrate gy with respect to y. Okay, so it will be e power y into 1 minus y. So now we have all the ingredients of our final answer. So I can write solution equal to original function f, which is this one, and plus g. Okay, so this is the solution. Okay, so minus 1 over t minus 1 over t plus e power y and into minus 1 plus y minus arc tan t over y plus log of t. So one thing which you can see is that this Mathematica use the word log, not ln, for the natural logarithm. So in normal hand calculations we use ln symbol, symbol, and then but here Mathematica use this as log. So this is the format in Mathematica. And also don't remember to put that equal to c. So in this case the final solution will be in the form of an equation. Okay, so maybe you can just manually put it like equal to c. Yeah, so this will be the okay, so this is the answer. Yeah, I just forgot to copy it correctly. It should be minus because it was minus here. Yes, so this is the answer. Okay, now take one more example. So this is the equation. Okay, so I can this equation is here, and this is the initial value condition. Okay, so I can rewrite this equation like this. Okay. Just I copy and paste. So I can subtract both sides by this value. So minus control V, and then from their side, but anyway, control Z. This side will be 0, and now I execute it. So I have got this equation in this form. So now m is equal to this control control C, control V. Okay, I will take a derivative of m with respect to y. So d m with respect to y, and then it will be 2y. Next I take the n function, which will be this value, and don't remember this minus sign. So minus bracket control V bracket close. This is n, and I take the derivative of this n x with respect to x is equal to derivative n with respect to x. So this is 0. So one is 2y, the other is 0. So therefore this equation is not exact. So you can write a comment over here that this equation is not exact. Next step is if this equation is not exact, we need to find an integrating factor. So we can find the integrating factor in both either Rx or both Sy factors. So let's take find some R, the function R. So function R is equal to 1 over nn times my minus nnx. Okay, so execute it. So this will be 2y over minus xy over y. So this function does not look as simple. So we can try another function. S is equal to 1 over m times nnx minus my. Oh, this is even more complicated. So therefore, maybe we can use the function r. It seems that I have made some mistake, and the mistake is in here, right at the very beginning. So when I wrote this equation over here, I did not put a gap between x and y. So therefore, Mathematica is considering xy as one variable. So there should be a gap, so that Mathematical should consider it is xy. Okay, so I need to correct this mistake. Okay, so I can correct it. Now I have this. So I need to use this value here over here. And now I need to execute it. And I need to execute it again also. Yeah, so now it is minus ny. And now I need to execute it. And I can also execute it. Here this can be simplified because y is in the numerator, y is in the denominator. So therefore, maybe we will not need to use this s function, which is still a little bit complicated. So, but we can simplify it. Okay. So simplify. Yeah. So it is minus 3 over 1 plus x. So we can use this minus 3 over 1 plus x for finding the integrating factor. Integrating factor we normally represent it by mu, the Greek letter, so I can just put mu over here. And the integrating factor is exponent of this r with respect to x. Okay, so I will yeah, it's not exponent of r, it will be exponent of integrate r. Okay, with respect to x, and then bracket close. So therefore the integrating factor will be 1 over 1 plus x cube. So now we can use this integrating factor to find the new m and new y. Okay, so new m is equal to integrating factor mu times the old m. So new m is this. Okay, and now the new n is equal to integrating factor multiplied by the old n, which was nn. Okay, so now we can check for its exactness. So I can take new m derivative with respect to y. It will be d, then it will be new m, okay, with respect to y. So it will be this 2y over 1 plus x cube. And I can calculate the new n derivative with respect to x. It will be d, it will be new n with respect to x. So it will be this. So it doesn't look the same, or maybe we need to simplify it. Yeah, let me simplify it. Simplify Bye.